In this lesson, we'll take a look at how to create an advanced timer. For its delay argument, this timer will take a single value of milliseconds for the delay or a table of values representing multiple delay values. If a table of delay values is sent to the timer will sequence the delay values in the order that they're represented in the table. So here at line 15, I've got a table called rates with 4 different delay values, each represented as milliseconds. So the timer will fire at 500 milliseconds, 1000, 500, and 250. Let's take a look at the result. The numbers are changing at 4 different rates. This is apparent because there's a sort of rhythm between the back and forth of the odd and even numbers, odd on the left and even on the right. Let's get started. To start, I've created a new retinatext object and have assigned it to a variable. This retinatext object features a creation argument of 0 because the idea here is that we're going to count up from 0 with our timer. The object is set towards the left of the screen with this equation right here. You'll notice that I'm using a single line creation argument, and there's a comma here, not a semicolon. So I'm setting x and y of the object with 2 different equations, the first and the second. The left equation uses the screen width, which is set as a constant here in lines 1 and 2, divides it into 4 equal parts, and then multiplies it by 1. This will position it more towards the left of the screen. We'll take a look. So there it is. This is where if we multiply by 1, and then if I multiply by 2, by 3, by 4, anyways, you'll get the point. Okay, so the next thing to do is to start working on the advanced timer class. And so I'll start by creating a line that calls the class, but I actually do have to create the file that has the class in a moment. So local advanced timer equals require, and then with quotes, advanced timer. Okay, if I were to render this now, I would get a fail sign. We need to actually create the class. I'll save the new file. And then I will get started by creating a variable, local advanced timer equals, and then it's a table, so we need 2 curly brackets, and I'll return this same variable. And the reason that we're doing this is because this is an external module, and so when it's brought in, it's basically bringing in a table here called advanced timer. Okay, so now in between these 2 lines, I will create the function that creates the advanced timer. Function advanced timer dot create and end. Within the create function of advanced timer, I will define the timer itself and its methods. So we'll start by typing local t equals, and then open and close curly brackets. T is a table. And as well, we're going to return t. Okay, so now in between these 2 lines, we'll define a few methods. Okay, the first is a start method, function t colon start. Okay, and end. So this one will be self-evident. This is how we start the timer. Function t pause and function t resume and function t destroy and end, and function t flush. The next step is to add the creation arguments to the start method. So the first argument will be the rate. The second will be a function to execute, or a callback function. The third argument will be the number of iterations, so how many times we want the timer to iterate. And the last argument will be something we call fast start. We'll now create some private variables that we'll use throughout the create function. So just before the start method, I'll type the following. Local rate, notice the underscore, local underscore function to execute, local underscore iterations, local underscore sequence, local underscore fast start. Now it's time to create the timer. Within the start method, we'll create the following. If not self.timer, then end. This line of logic prevents us from creating two timers with the start method. So basically, we're going to create a timer and store it within a property called .timer. If that doesn't exist, then we'll actually create the timer. However, if it does, we're just going to skip over the block. Now within this conditional block, we'll type self.timer equals timer.performWithDelay, open and close parentheses. Now the first argument takes the delay time in milliseconds. Here we'll type underscore rate. The next is the callback function, or the function to execute. We'll create an anonymous function. And then the number of iterations. So underscore iterations. Let's store the values that are fed into the creation arguments for the start method to their private counterparts. Underscore function to execute equals function to execute. Then underscore iterations equals iterations. And lastly, underscore rate equals rate. We're designing the advanced timer to be as flexible as possible. This means that we'll design flexibility around the rate argument. Rate here can be two different types of values. It can be a number or a table of numbers. If it's a single number, advanced timer will essentially work just like a regular timer. If it's a table of numbers, then advanced timer will fire according to the order of the table of numbers, each number representing a delay value. So we'll need to write some code to detect what type of value rate is. To do this, we'll type local r equals type, open parentheses, rate, and close parentheses. In Lua, the type function is used to detect the data type of a variable. Now we can create a condition that acts according to the type of variable that rate is. If r double equals, and then in a string number, then, and this is code if r is a number. Else if r double equals table, then end. And so this is if r is a table of values. Let's deal with the first condition, the rate being a number. If the rate's a number, we'll simply pass along the rate argument to the underscore rate variable. Underscore rate equals rate. If the rate is a table of values, the logic is a bit trickier to deal with. First, we'll assign the rate argument of the function to the underscore sequence variable. Underscore sequence equals rate. Now, we'll create a local variable called mod that will store the length of the sequence. We'll do this under the declaration for r. Local mod, but we won't assign a value. Instead, underneath underscore sequence equals rate, we'll type mod equals hash rate. Remember that in Lua, the hash sign before a table value returns the length of the table. If you're wondering why the mod variable at line 21 was declared local but with no assignment, It's because we'll be wanting to use this variable throughout the entire function block. And this includes self.timer. If we would have declared mod as a local variable at line 31, we would be able to use it within this code block only. We're going to leave the mod variable for now and return to it when we're ready to code the pause method of the advanced timer. We'll move on by working with the fastStart argument of the function. The fastStart argument will allow the timer to immediately execute when it starts, as opposed to waiting for the first delay value before the first iteration occurs. So if the fastStart argument is set to true, we'll want to make sure that the timer immediately starts. If fastStart, then _rate equals 0, _fastStart equals fastStart. End. Right now, this is admittedly a bit cryptic. This will make sense in a moment when we start to actually code the timer that's at the heart of the advanced timer class. At line 39, we've already created a timer and have assigned it to a .timer property of the class. Now, within this code block, we'll do the following. We'll first implement the fastStart feature of the advanced timer class. If fastStart and r equals number, then and end. So here, if the fastStart option is set to true and the rate variable is just a number, meaning that there's no sequence, we'll do something. Before going any further, we're going to create a local variable outside of this code block that refers to the advanced timer object. So above self.timer, we'll type local s equals self. The reason we can't do this within the self.timer block is because self would refer to this anonymous function and not to the advanced timer. We'll head back to the code block we were just working on. Within this code block, we'll type the following. s.timer._delay equals rate. And on a new line, _rate equals rate. What we're doing here is we're referring to the timer through s.timer. And then we're accessing the _delay property of Corona's native timer. This isn't quite well known, but you can access and change the delay property of a native Corona timer by typing ._delay on any Corona timer object. Before we move any further, let's test what we have. So underneath the current code block, we'll type function to execute parentheses e.count and save it. Remember that function to execute is an argument for the advanced timer class. We'll head back to the main.lua file. And underneath the retinatext object, we'll type local tmr equals advanced timer.create. Then tmr:start, open and close parentheses. The first argument is a delay value. We've only coded it so that it'll accept a single value. So let's type 500. For the next argument, we'll create an anonymous function. Function end. And then we'll have it iterate one time. Within the anonymous function, we'll set the text property of the object to reflect the current count. obj.text equals e. Remember that we're already passing the current count of the timer through e. We don't need to type e.timer as we do with native Corona timers. We'll save it and then render it in the simulator. To be extra sure that the timer is removed from memory when it's stopped, we'll code the following. We'll go back to advanced timer and head down to the last portion of the self.timer code block. Underneath function to execute, we'll type the following. If iterations does not equal 0, then end. Within this code block, we'll compare the current count of the timer to the total number of iterations the timer is to actually occur. We'll type if e.count double equals iterations, and then end. So if the current count of the timer equals the total number of times the timer is to iterate, we'll cancel the timer, timer.cancel, and type s.timer. Then we'll nil out the timer, s.timer equals nil. This is a good practice with any kind of timer, whether it's your own custom timer or the native Corona timer. When you're done with the timer, you should cancel it using timer.cancel, and then you should nil out the variable reference. Remember that we've created this entire code block so that if the self.timer reference is nil, it'll run through the entire timer creation. The next feature that will be implemented in the advanced timer is an elapsed count property. This property will keep track of the current count of the timer. This is helpful so that if the timer is ever paused, we can update the elapsed count when it's resumed. We'll head up to the top of the code block, and underneath _rate, we'll type the following: self.elapsedCount equals self.elapsedCount or 0. What's happening here is we're creating a property called elapsedCount, and we're assigning it either to itself or 0. This may be confusing at first, but if we're restarting the timer, we're going to actually store the previous count in elapsedCount. So that's why we're first checking to see if self.elapsedCount has a value, and then setting it to itself. Or if it doesn't exist, we'll simply assign it to 0. Now is a good time to implement the pause method of the advanced timer. We'll head down to the pause method. Just after t:\pause, we'll test to see that the timer actually exists. This will prevent us from calling the pause method if there's no timer. If self.timer, then end. When we pause the timer, we'll want to store the elapsed count. Self.elapsedCount equals self.count. Note that we have yet to create self.count. We'll do that in a minute. Since the resume method is going to eventually create a new timer, we'll go ahead and destroy this timer in the pause method. Timer.cancel self.timer. And we'll follow that with a nilling out of self.timer. Self.timer equals nil. Let's create self.count within the start method. s.count equals e.count plus s.elapsedCount. So we're setting the count property of the advanced timer to the current count of the timer plus the elapsed count in case we paused. And remember that the elapsed count is set to either the previous elapsed count value or 0. So if this is the first time the timer is running, then the elapsed count will be 0 here. So we're really only setting s.count equal to e.count. With elapsed count defined, we need to head back to the code that tests for the data type of the rate variable. Underneath mod equals #rate, we'll type the following: if self.elapsedCount, then end. So here, the idea is if the timer is paused, we'll want to pick up where we left off in the sequence. We'll create a local variable called I, and we'll set it equal to the most complex statement that we'll have in our code so far. I'm going to create what's called a ternary operator. A ternary operator is a bit of code that consists of 3 parts. There's a conditional check, and then there's a value if the condition is true, and a value if the condition is false. So for the conditional check, we'll test for self.elapsedCount modulo, which is the %, mod equals 0. Then we'll type and mod, type or self.elapsedCount. modulo mod. So I'll go over this bit of code piece by piece. First, there's this conditional check that's within parentheses, and then if this is true, we'll use this value here. If it's false, we'll use this value. What this is doing is it's checking for the value of elapsed count, and if it modulo whatever the mod value is, which remember that's the length of the sequence, is equal to 0, otherwise we'll use the elapsed count modulo the length of the table. Here, you might want to print the value of I so that you can see what it is when elapsed count kicks in with this condition. I'm going to actually leave it out. We'll use the I variable in this way. Underscore rate equals underscore sequence bracket I. We're setting the underscore rate variable to the value that's located at the index returned by I within the sequence. Now we'll go outside of this condition block. We'll change the end to else because it might be that self.elapsedCount is not set. So else end, and here we'll type underscore rate equals underscore sequence bracket 0. So this way, if self.elapsedCount isn't set, we'll always use the first value in the sequence as the rate. The last thing we need to do is go into self.timer and implement a condition if fast start is true and R is a table. So we'll type if fast start and R double equals table, then end. Now we'll type local I equals, and we'll use another ternary operator, s.count modulo mod double equals 0 and mod, or s.count modulo mod. I'll break this down. So if s.count modulo mod, which is the length of the table, equals 0, then we'll use the length of the table as the value. Otherwise, we'll use the result of s.count modulo the length of the table, which is mod. We'll set the delay property of the Corona native timer, s.timer.underscore delay, and the underscore is really important here, equals rate bracket I. Remember that rate is a table, so we're setting the native Corona timer to the value at the index represented by I. As helpful feedback, we'll print the current value of the rate table. Now it's time to finish out the rest of the advanced timer class. Remembering that in the pause method, we actually destroyed the timer. When we resume it, we'll need to create a new timer by calling the start method of the class. First, we need to make sure that a timer doesn't actually exist, because resuming assumes that the timer has been destroyed. We'll type if not self.timer, then end. So this will only run if self.timer doesn't exist or is nil. Local R equals sequence or rate. There are only two choices here. We'll either have a single value for a rate, or we'll have a table of values for a rate, which is represented by sequence. So if sequence has a value, then we'll assign that to R. If it doesn't, we'll default to rate. Then we'll call the class's start method, self::start. And this is why we've created the underscore private variables. We'll feed R as the first value, which is the delay. The next is underscore function to execute, comma, underscore iterations, comma, underscore fast start. Let's code the destroy method. This method will completely kill and destroy the timer. If self.timer, then end. We'll cancel the timer, timer.cancel self.timer, and we'll nil it out, self.timer equals nil. Lastly, we'll clear out all of the properties of the object, self::flush. Since we have yet to define the flush method, let's move and do it now. For key, comma, value in pairs, parentheses self, do, end. Self bracket key, end bracket, equals nil. What we're doing with this block of code is we are looping through key value pairs of self, and wherever there is key as a property of self, we're nilling it out. This is just good practice to make sure that we've cleared out all of the properties of the timer. Before testing this out, I need to point out that I did actually make a mistake, and it was here at line 60. We should just test for R being a table, not having fast start and R being a table when we're actually implementing the table within the timer. So a mistake on my part there. We'll now head back to the main.lua file, and instead of a single value for our delay value, we'll use a table. So open a curly bracket and close it, and within that we'll type two different delay values, 250 and 750. We'll have this iterate 10 times, save it, and run it in the simulator. Okay, you can see that there's a rhythm there, and as well we printed out the delay values as they occurred, and we're getting 250, 750, and it's just looping around. Last, we'll substitute this anonymous function with an external function to call. To save time, I'll copy the function and paste it above the start method. Now we'll substitute the anonymous function with the method. Count in this particular case is the count that's fed from the timer. So what we're doing is we're alternating between two different counts. If the count modulo 2 is 1, then we'll have the object appear towards the left. If count modulo 2 equals 0, we'll have it appear towards the right. This will cause an alternation of left and right, odd and even numbers. Instead of setting a table directly within the method, we can also set it to a variable. Let's run it in the simulator and see what happens. Finally, to demonstrate the pause and resume methods of the advanced timer, I'll paste some code that utilizes a runtime touch event listener to swap back and forth between pause and resume. Here, I've got a variable called pause that acts as a flag. It's initially set to false because the timer will run and it's not paused. Within the runtime event listener, in the ended phase or canceled phase of the touch event listener, there's a conditional block. If the pause variable is true, that means that the timer is currently paused. So to unpause it, we'll call the timer's resume method, and we'll set the pause variable to false. Otherwise, the timer is going and we need to pause it. So we'll call the pause method of the timer and set the variable to true. Before we test it in the simulator, let's head back to advanced timer. There's one really small detail that we need to change. On line 66, under function to execute, we were sending the native count of the timer. We need to send the count as it's stored within the timer object. We need to send the count as it's stored at line 53. So we'll change it from e.count to s.count. Save it and test it in the simulator. I'll tap the screen to pause, and when I tap again, it resumes. It bears mentioning that at least at the authoring of this video, there is a native pause and resume method to the Corona timer. The reason that I chose to implement a custom pause and resume method for this advanced timer is to ensure that should a table of delay values be used, that the count would remain consistent in pause and resume. You could still access the native pause and resume methods if you wanted to by simply drilling down to the timer property of the advanced timer object. To do that, you would type the name of the object as you instantiated it, .timer.pause with parentheses. For a small fee, you can download the project files for this tutorial at cheetomoskeeto.com.